Welcome to this comprehensive guide on Selenium interview questions. Selenium is an open-source test automation framework specifically designed for automating web applications across multiple browsers and platforms. At its core, Selenium consists of three main components. WebDriver is the primary component for browser automation, allowing you to control browsers programmatically. Selenium Grid enables parallel test execution across different machines and browsers, making your test suite run faster. Selenium IDE provides a record and playback tool for creating simple automation scripts without coding. Understanding these fundamental components is crucial for any automation testing role, as they form the foundation of most modern web testing strategies. WebDriver represents the heart of Selenium automation. Its architecture follows a client-server model with four key components working together. Client libraries provide language bindings for Java, Python, C#, and other programming languages. The JSON wire protocol serves as the communication bridge between your test code and the browser driver. Browser drivers like Chrome Driver and Gecko Driver act as intermediaries that translate your commands into browser-specific actions. Finally, real browsers like Chrome, Firefox, and Safari execute the actual automation tasks. The basic WebDriver workflow is straightforward. Initialize a WebDriver instance, navigate to a URL, find web elements, perform actions like clicking or typing, and then close or quit the driver to free up system resources. Element locators are fundamental to Selenium automation as they help you identify and interact with web elements on a page. There are 6 primary locator types you should master. ID locators are the most reliable, as IDs are typically unique on a page. Name locators work well for form elements that have name attributes. CSS selector locators are fast and flexible, offering powerful selection capabilities. XPath locators handle complex scenarios where other locators fail, though they can be slower. Class name locators work for elements sharing the same CSS class. Link text locators are specifically designed for hyperlinks. Here's a basic Python example. Import the necessary modules, initialize a Chrome driver, navigate to a URL, and find an element by ID using the find_element method with by.id parameter. Waits are crucial for handling timing issues in web automation, especially with dynamic content loading. Selenium provides 3 types of waits. Implicit wait sets a global timeout that applies to all find element operations, continuously polling the DOM for the specified duration. Explicit wait offers conditional waiting for specific elements with precise control over timing and conditions. Fluent wait provides the most flexibility with custom polling intervals and exception handling capabilities. Here's an explicit wait example. Import WebDriver wait and expected conditions, create a wait object with a 10-second timeout, then use the until method with element to be clickable condition. This approach is more reliable than implicit waits and should be your preferred choice for production code. Never mix implicit and explicit waits in the same test, as this can lead to unpredictable behavior. The page object model is a design pattern that significantly improves test maintainability and code organization. In POM, each web page is represented as a separate class, with web elements becoming class variables and user interactions becoming methods. The typical project structure includes a pages folder containing individual page classes like loginpage.py and dashboardpage.py, plus a tests folder with your actual test files. POM offers 4 key benefits. Code reusability allows methods to be shared across multiple tests. Easy maintenance means UI changes require updates in only one place. Better readability makes tests more descriptive and business-focused, and reduced duplication eliminates repetitive element definitions. This pattern is essential for scalable automation frameworks and is frequently discussed in interviews. Let's examine how to implement page object model in practice. A typical login page class starts with an init method that accepts a driver parameter and stores it as an instance variable. Define locators as class attributes using tuples containing the by strategy and selector value, such as username field equals by .id, username. Create action methods that perform specific tasks, like enter username method that finds the element using the stored locator and sends keys to it. In your test class, initialize the page object by creating a login page instance with your driver. Then call the page methods to perform actions like entering username and password, clicking login, and verifying results. This approach separates test logic from page structure, making your tests more maintainable and readable. Page Factory is an extension of the page object model that uses annotations to simplify element initialization. It provides several advanced features that reduce boilerplate code. Find-by annotations allow declarative element definition with various locator strategies like ID, CSS selector, or XPath. Lazy initialization means elements are only initialized when first accessed, improving performance. The PageFactory.initElements method automatically initializes all annotated elements using a proxy pattern. Clean syntax significantly reduces the amount of code needed compared to traditional POM. Here's an example. Define a class with find-by annotations for each element, use the init method to call PageFactory.initElements, and then access elements directly as if they were regular variables. This pattern is particularly popular in Java-based automation frameworks. Cross-browser testing ensures your web application works consistently across different browsers and platforms. Selenium supports all major browsers including Chrome with its Chrome driver, Firefox with Gecko driver, Safari with Safari driver, and Microsoft Edge with Edge driver. Cross-browser testing provides several critical benefits. It ensures consistent user experience across platforms, helps identify browser-specific issues early in development, validates responsive design behavior across different rendering engines, and ensures compatibility with your target audience's preferred browsers. Implementation involves creating a driver factory method that returns the appropriate WebDriver instance based on a browser parameter. You can then use parameterized tests with frameworks like PyTest to run the same test across multiple browsers automatically, significantly improving your test coverage. Test automation frameworks provide structure and organization to your automation efforts. There are 5 main framework types to understand. Linear framework follows a record and playback approach with sequential test execution, suitable for simple scenarios. Modular framework divides test scripts into independent, reusable modules. Data-driven framework separates test data from test scripts using external files like CSV or Excel, enabling the same test to run with multiple data sets. Keyword-driven framework defines actions as keywords, making tests accessible to non-technical team members. Hybrid framework combines multiple approaches for maximum flexibility. Framework benefits include code reusability through shared functions, easy maintenance with centralized changes, scalability as the framework grows with project requirements, better reporting with comprehensive logs and results, and parallel execution capabilities for faster test completion. Exception handling is critical for creating robust automation scripts that can gracefully handle unexpected situations. Common Selenium exceptions include no such element exception when an element isn't found with the given locator, timeout exception when elements aren't available within the specified wait time, stale element reference exception when an element is no longer attached to the DOM after a page refresh, element not interactable exception when an element is present but not interactive, and WebDriver exception for general communication errors between WebDriver and the browser. Proper exception handling involves using try-catch blocks around potentially problematic operations. For example, wrap element finding and interaction code in a try block, then catch specific exceptions like timeout exception and no such element exception to provide meaningful error messages and alternative actions. Advanced WebDriver features extend your automation capabilities beyond basic interactions. JavaScript execution allows you to run custom JavaScript code directly in the browser context for complex operations. Window handling enables switching between multiple browser windows or tabs using window handles. Frame switching helps navigate between iframes and main content using switch to frame methods. Alert handling provides methods to accept, dismiss, and interact with browser alerts and confirmation dialogues. Screenshot capture takes full page or element-specific screenshots for documentation and debugging. Cookies management allows adding, deleting, and retrieving browser cookies for session management. Action chains support complex user interactions, including mouse actions like click, double-click, right-click, and hover operations, drag and drop between elements, keyboard actions for key combinations and special keys, scroll actions for page navigation, and multi-touch gestures for mobile automation scenarios. Following best practices ensures your automation scripts are reliable and maintainable. Key practices include using unique locators, preferring ID and CSS selectors over XPath for better performance. Implement explicit waits instead of thread.sleep to handle dynamic content properly. Maintain regular test maintenance by updating scripts when the application changes. Use fresh browser instances for each test to avoid state pollution between tests. Implement data-driven testing by separating test data from test logic. Enable parallel execution to run tests concurrently for faster feedback cycles. Common interview questions you should prepare for include: what is the difference between driver.close and driver.quit? How do you handle dynamic elements in Selenium? What's the difference between POM and Page Factory? How do you implement cross-browser testing? What are implicit versus explicit waits? How do you handle multiple windows in Selenium? What is Selenium Grid and its benefits? How do you take screenshots on test failure? Understanding these concepts and practices will significantly improve your interview performance.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.